Hello everyone, welcome to CYBR603 Learning Activity 6, and we are going to cover Project Moonbase. This is actually what we are going to use as our framework to develop our understanding of integrated systems architecture as it relates to VMOS, as it relates to DODAF, as it relates to SCQA. And we're going to use Project Moonbase to get this started. As I talked about in our last lecture in Learning Activity 5, I talked about the all view one and then the capability view one. And we're going to use Project Moonbase to help frame up those assignments for you so that you're not just kind of like, well, I'm going to create an all v1, an AV1 and a CV1, but what am I working towards? What am I working, for? In this case, we're working for the creation of a moon base. And I love using the moon base because there's a lot of moving parts and it gives us a lot to work with. Okay, so first up, there's a nice article out there in News of Scientist on NASA planning a permanent moon base, and there's a lot of nice little tidbits, but it gives you a very good framework for actually constructing an AV1. So jump out there. You don't have to use that one. That's a good one to read up on. There's a lot of moon-based articles out there, so you can find all kinds of fun stuff to work with. But let's. I'm gonna take an implementation view of things to consider for an implementation of a moon base, and so this is something that has implications for our architecture. As an enterprise systems architect for the moon base, we're going to be in charge of all aspects of it, not just the technical aspects of it, but every aspect of this moon base. And so what that means is we have to have an understanding of the interrelated items. We have to have a very good understanding of the scope. We have to have a very good understanding of the integrations. We even have to have an understanding of policies, training. We have to understand if this was to be implemented, we have to have a good visibility across all of it. So what that means is we have to have an understanding of, if we were going to implement this, what would the implementation plan look like? So of course that has a lot of different question marks. Now, these are things that you need to be thinking about as you're going about the development of the architecture. First up is readability, and then next up is maintainability, performance, traceability, correctness, and completeness. These are kind of the core part, good characteristics of a good implementation plan. And so why are we talking about implementation plan when we've been talking about architecture all this time? Well, this gives you a way to help ground your architecture in reality. It's one thing to go out there and say, hey, I'm going to create an architecture just for the sake of creating an architecture. It's another thing to actually get that into a place where it's understandable. So readability or usable, and makes sense for we're going to implement it, right? I mean, that's what we build an architecture, not just for an architecture's perspective, but so that it can be either understood or implemented. Okay, so let's go into each one of these. So from a perspective of components of implementation, here is the use case. And we're building out a moon-based ecosystem that's going to have all kinds of fun things. You can see here, it's a simple one. It's one that I just made up. I didn't make this diagram, but it's one that it's a nice one to understand. We got a lot of moving parts. We got a gym, sleeping quarters, we got water tanks, meeting areas, labs. We've got a common area, and then we've got a storage area, common systems and storage area. So there's a lot of different things that are going on here. It's a simple moon base. You got an egress, ingress. It's a single input, output. One area for people to come in and out of. Okay, readability. So one of the components of being able to do this is we got to have program documents, blueprints, architecture, surveys, system capabilities, system parameters. It kind of looks familiar, huh? Some of the stuff we've talked about up to this point. One of the things that we haven't talked about is parameters. Documents, we kind of understand. Blueprints, architectures, yeah, okay. Aerial surveys, yeah, that's kind of more on the exploratory side of it. System capabilities, right? Sounds like a CV1 to me. System parameters. System parameters are very important, especially when we talk about moon base. That's one thing that we'll talk a little bit more about as we move along. So maintainability, right? Whatever we develop has to have some kind of ease to access. We have a need. There's the parameters again, measurement of system parameters, modularity of components, availability of tool sets, logging, service logging. Sounds like a service view, right? Sounds like a system view. Sounds like we got a lot of things that are starting to show up. That's why this moon base is such a nice project, because we got a lot of different things that we can work with here. All right. Performance, back to parameters again, audio visual systems, system parameters, human parameters, the system response times as it relates to those parameters. We're back to parameters again. A moon base has to have, there's tolerances, right? I mean, what does the air quality have to be like? What's the air temperature have to be like for humans? That these are operational parameters that need to be understood. Parameters. So system architecture, our system architecture needs to take into account parameters, both system and human. There also has to be traceability, functional requirements, non-functional requirements, a traceability matrix of said requirements, and then design traceability. And when we say design traceability, we're talking about traceability from the beginning of within and through an architecture, but that also means that the life cycle traceability, that means that a requirement that I establish early on in an architecture and shows up in an architecture needs to make its way through not just design, but development and through to production. That's what traceability we're talking about here. So from requirements to implementation. All right, correctness. When we talk about correctness, we're talking about independent verification, customer validation. That's usually called an IV&V function. So for people that are familiar with how the government works or how high-end research works, usually there's what's called an IV&V function, or independent verification and validation. IV&V is very, very useful. When you're in the personal development space, IV&V is usually just a testing function. Independent testing. You might have an independent test organization. You might have integrated testing within your development core. In other words, your developers might be doing their own testing. You might have a quality assurance it's verification and validation from a different perspective. Regardless, usually there's some kind of form of an IV&V function. Really big products or really big projects like this, like a moon base or an aircraft carrier or an airframe or a bomber or a car, whatever it is that you're developing. If there's a lot of customer human interaction and safety is of concern, there's probably going to be an independent entity that does the verification and validation, separate and apart from the organization that is developing the product. And that's for conflicts of interest, right? Because if you're developing a car, you probably want to have a third-party organization developing the car, because let's say there's a defect. Well, if the manufacturer has every incentive to kind of cover up a defect to try to for profit purposes, right? So that's why you have usually an IV&V function to help make sure that corners aren't being cut. Another piece is you got completeness. So this goes back to traceability as well. But the initial requirements that were outlaid and outlined for the architecture are actually maintained throughout to the product's deployment. So it would be kind of one thing to develop a moon base and only have half of the requirements developed, right? So let's say I created a moon base that didn't have a laboratory. Well, it doesn't help us with science. That means that we have missed in the completeness section. And again, back to design traceability. So completeness is very important. We need to make sure that what we architect is something that's, one, feasible to be architected and is grounded in reality, and two, is able to be architected towards a vision that is complete. Okay. So the final project, so this is it. We're working towards a comprehensive project Moonbase architecture. This is what we're going to be working with. This is what our artifacts that you're going to be developing are going to be grounded in. You will have artistic license. You have to create these artifacts, but you have artistic license into how you create the artifacts. What goes into them is up to you, based on what we do, but they have to be comprehensive. And they will culminate in a PowerPoint presentation at the end of the semester where you're going to present, you're going to record it, and then those presentations will be evaluated. So you want to make sure that your artifacts are comprehensive and that you have a coherent story and that they're interlinked throughout. In other words, what that means is your AV1 makes sense with your CV1, your CV1 makes sense with your SV1. They all tell a coherent story. So more details will become available as we move through the course, but this is pretty much what we're going to be working with. Other than that, I think that's all I got. So let's see, what do we have here? So let's get moving on the Moonbase. So so your assignment for this week is to create an AV1. It doesn't need to be as comprehensive as the example. I just need you to create a single page AV1. Keep it brief, keep the descriptions brief, keep the AV1 components down to a minimum. I will leave it up to you. I would like to see a core. Remember those 5 bulleted core items I talked about? There's a top 5. If you stick to the top 5, you're going to be in good shape. But give me enough information that I understand that it is a comprehensive AV1. Okay. Again, keep it to 1 page. I don't want it to be as long as the example that's out there. It's like 6 pages. It doesn't need to be that long. So use that as inspiration is what I'm saying. CV1 is going to be using diagrams.net or another visualization diagram tool of your choice. It could be Visio. It could be it could be another tool entirely. Whatever you want. So it just needs to be able to describe, remember the CV1 that we showed earlier, it needs to be able to describe that. Don't forget, you can use Google to look at other examples of CV1s. You can also use Google to look at other examples of AV1s. There's different flavors of these. No one way is the right way to do it. What I want you to do is use your own artistic license, use your own best judgment to create a comprehensive AV1 for me and a comprehensive CV1 of a Moonbase. It's not going to be perfect. It's going to be abstract, and that's okay. If you have questions, let me know. But page 1 is the AV1, and page 2 is your CV1. So that's all you have. That's all you need to have for this week's assignment. I highly recommend that you definitely go through all these videos, think through Project Moonbase, do some research on Project Moonbase, find some other material. Anything and everything is open and available to you. This is part of the research process. Use the internet to your advantage. There's tons of information out there. You're only creating 2 pages here. So I want you to go out, look about moonbases, go to Wikipedia, research on moonbases, go to googlescholar.com, look at moonbases, do some research. The more research you do, the quicker the AV1 and the quicker the CV1 fills out. But these are based on you and your own personal areas of interest as it relates to this Moonbase initiative. So I want you to build it out. You're building a Moonbase. What does the AV1 look like? You're building a Moonbase. What capabilities does that Moonbase need to have? That's your 1-pager. And then, your 2-pager. Your 2-pager. So that's all I got. If you have any questions, you know where to find me. Feel free to email or text. And that is all I have for this week. We will see you next week.